Okay, so welcome, Todd. Todd is the Vice President for Aerospace and Defence Strategy at Siemens. Thanks for introducing you to your lovely stand here today. It's very nice, and I'm sure you've been having a good day so far.
Had a fantastic day. There's nothing better than having my discussions with customers interrupted by jet noise all day long. That is just, it makes my day.
Yeah.
Lee, it is fantastic to be here. I'm excited to be on the podcast. This is going to be fun.
There's been some quite noisy jets out
quite
there
noisy
today.
jets, yeah. We've had lots of military jets, lots of commercial jets, lots of really cool aerospace products. I mean, it really, it helps me understand and remember why we do what we do.
Yeah.
What we do is really cool, it's really exciting.
And it brings everything to life, doesn't
it? It does, it brings it to life, no question.
Look, before we chatted, we just had a demonstration in your chalet about immersive engineering with your launch partner, Nautilus. There's one going now. Just explain what immersive engineering is. It's one of those tech terms that maybe most people haven't heard of. What does it mean?
So what is it? So think about the way we've done kind of the progression of digital engineering. We've gone from slide rules to paper to PDFs to 3D models, and we've always lived in. We've tried to create these 3D products, and we've done it with flat screens. So it's this 2D representation of a 3D world. Okay. So in simple terms, what immersive engineering lets us do, it lets us step into the 3D world of mechanical and physical design. And it lets you do with the kind of this headset. Yeah. And you can say, okay, but so what? Yeah. There's 50 headsets on the market. The cool thing, the differentiating thing about immersive engineering is that our tool, our Sony headset, is connected to real physics. It was designed from the ground up to work with our groundbreaking mechanical design software, and it allows engineers to design, manipulate, and work with real 3D data, physics-based data in real time. Yeah. So that's step one. It's our window into the metaverse, but that's great. Yeah. But then you can say, okay, well, we live in this post-COVID world where we don't travel to face-to-face anymore. We've done all these meetings on Zoom and Teams. Okay, the other thing this lets us do, I can wear the headset here in London. My colleague can wear a headset in New York. Someone else can wear a headset in Tokyo. Yeah. We can step into this metaverse, all three of us with headsets on. We can see each other. We can walk out to the virtual flight line, up to our virtual aircraft, and see it and experience and collaborate on it in real time. Yeah. Again, and I keep saying this idea of physics-based, because we've had these physics-based tool sets, and design, digital transformation forever, that we've lived in this 2D representation of the 3D world. This brings the cool 3D things we do in aerospace to life in 3D in front of us in a digital twin, and really lets us work in that collaborative space in a single source of truth. All at once. I think it's game-changing technology. It changes the way engineering will be done in the future.
So it's collaboration, as you said, which means you can collaborate over thousands of miles.
Over thousands of miles,
but
that's right.
Does it make the end product different than what it would have been if you were doing it in the traditional way?
I'll give you an example. Nautilus is here. Yeah. The Nautilus CEO, Alexei, is here. I was standing with him at a demo earlier today, and somebody asked him about the benefits of this. He said, okay, here's a real-time example. He said, the first time one of my designers put on the headset, walked out to the aircraft. Number one, it's a visceral experience, kind of an emotional experience to see your creation finally in real life. So that's thing one, because usually it takes a real aircraft to do that. And then he said he walked up, he'd been working on clearance on a door. He picked up the door in 3D space and hit something. He said, crap. And he realized immediately that he'd missed that in the design. Yeah. And I asked Alexei later, I said, okay, Alexei, how much did that save you to find that now, rather than once the airplane rolled out on the flight? He said, it's 1,000x, Todd. It's 1,000x. Yeah. That's why this is game-changing technology to allow us to find and measure and see things. We live in 3D, we think in 3D, our products exist in 3D, they should be designed in 3D.
And so you can make mistakes in 3D.
Well, you want to make those mistakes in the digital. They're so much cheaper in the digital twin, and it allows us to develop, find, and create so much faster in 3D, and not have to reminds you that translation from the flat screen to real 3D. That's the game-changing part of this.
What's certainly interesting when you get into the aviation sector, as I have, and you have been for many years, is you see this happening in a real-life situation, a scenario. Right. It's a use case. Right. Well, you said metaverse.
Right.
Outside of in the public realm, metaverse is this thing that Facebook's playing with.
It's a game. It's a game,
exactly.
right?
And people think it's just frivolous, and pointless. It won't go anywhere.
Right.
But when you see these kind of use cases, you think, actually, this thing's going to be built. Every airline will have a digital twin of its airline flying around the world. And therefore, it's one step between allowing the customer then to enjoy that metaverse that they've created. They created it for real proper business reasons and commercial reasons, and that's what's happening, isn't it?
Yeah, exactly. In just a few years, it will be economically unsustainable to deliver a product that you didn't first test in a 3D world.
Right.
Because you just won't be able to.
You won't be allowed to, maybe.
You can't afford to have the mistakes once you build it.
Yeah.
Just the margins won't allow it to happen. That's where our world is going.
So let's talk about the other big buzzword at the time in tech, AI, and how that's going to change things. So this is about design and in aerospace and in defence. I've actually seen it in practice a few weeks ago. I visited the Aston Martin Formula One HQ in Silverstone, and they've got parts. They were showing us a part that was developed by AI for suspension on one of the F1 cars. It was a shape that no human would have come up with. It was clearly built, and it was bizarre, really, because it was in a very strange shape, but it was optimized for what they needed for. Is this what we're seeing now being used in aviation?
We're seeing it in so many levels, and you talk about F1. Let's talk about F1 for a minute. One of the cool things to me about F1 versus aerospace are the time frames. They're compressed, right? I have a race week to week. I've got to make that design change week to week. We have nowhere near the kinds of real-time collapsing schedules, but we have similar kinds of needs in aerospace where we need to collapse that development time. AI is letting us do that in all kinds of ways. And if you think about AI and all the benefits it can bring to aerospace, it's certainly I'll call that topology optimization, is what was probably happening with that F1 car. And that's certainly an aspect that we're delivering, and I'm just talking about delivering at Siemens right now in terms of topology optimization. But there's so many other things. And if you think about it in terms of automation, and we talk a lot about automating mundane things people don't want to do, and then automating complex things that we thought only people could do. And AI is enabling automation in all aspects of development. I'll give you a few examples, okay? So a simple example, if you think about it, we have a large airframe manufacturer using our generative design right now to do generative development of wiring designs for aircraft. You think about a business jet, it's designed once, but every single jet that's built is built for a custom person and has a new, different kind of electrical wiring system as unique for that particular, because there's different options, different seat configurations, different lights, okay? And we have software that's in production, that's being used right now, that does generative design of that whole wiring layout. And then not only does it have to be designed once that way, but it's got to be maintained for 30 years. And to do generative design of all the support material. And our customers telling us that it's saving them more than 90%, 90, of the thousands of hours it normally took to do that. And it gets rid of all that mundane work. So that's an application of that. We also have, and we're also using generative AI as part of our PLM products to really allow customers to visualize and use all of their data and search it and make connections and find patterns in ways they've never been able to find before. And that's just scratching the surface of where we're at there. There's just so many applications for AI in aerospace right now.
Of course, in aviation, this is happening in a highly regulated space.
Absolutely.
No getting around that, and there never will be a getting around that. And one of the issues of AI in general is trust. So those two things could clash. Where are we with that? Are the regulators sort of seeing the promise of this so that they are allowing it to be used? Or?
Well, so if you think about that, when we talk about AI at Siemens, we talk about it in terms of industrial AI. And you're right. And what the world is that buzzword? What's the difference? Well, when I think about AI like ChatGPT and the AI we're talking about, I'm thinking about industrial AI that is secure, because we're talking about mixing customers' data with public large language models. So we've got to do that, and we've found ways to do that in secure environments that protect customers' data, but it's also got to be physics-based. And that's the difference. And when we talk about AI, we're not talking about Skynet. We're not talking about pushing a button and having an aircraft come out the other end that nobody tested. We're talking about the state of the art right now is assistive technologies that help, that I don't give the engineers the one best answer that's accepted. I take a universe of 1,000 answers, and I do all the work to say, okay, here's the 5 best ones. And those 5 best answers are presented to a real human engineer who can then take the time to whittle that down to the one best answer and validate that it's right. So that's how we're using it with respect to regulation right now. Nothing's going out the door without the touch of a human engineer, but the path it took to get there, which might have been this long path of looking at 1,000 iterations, now I just have the human engineer to look at the last 5.
Yeah.
It's about time to market, it's about speed, it's about creating an environment that's a much better place to want to work in than what we had before, because all that mundane work is going to be done by the AI.
And if there's anything the industry needs at the minute is a bit of compression of timelines, more speed. And we're struggling as an industry
and
to
more
keep up with
workforce,
demand, don't we?
And more workforce, right? And how are we going to deal with the workforce issue?
We'll talk about workforce in a minute,
Okay.
but just to finish this idea on the technology side of things, that my first chat this morning when I got here was about how the industry can embrace a kind of almost Tesla-style way of designing and taking the tech. So the software almost determines what the hardware looks like. You know, the way that Tesla redesigned how you make cars. It looks like a car from the outside.
Well, we call it
a
software-defined vehicle is what we call it, right?
Which is it, and your modern aircraft is a flying computer.
Yep.
Is it not?
Absolutely.
So what is Siemens doing in this area to say, like, okay, these things are now flying computers. The software is just as important as the hardware, and the software needs to be able to be configurable. It needs to be flexible, and it also needs to be future-proof as well. So you don't have to continue to change things.
Yeah, and that looks like the aspect of complexity. And the designs that our customers are having to put up to develop now are just orders of magnitude more complex than they used to be.
Yeah.
You talk about software-defined vehicle in a car. Well, now look at a drone and all the things that an advanced air mobility taxi would have to do, or maybe a defense kind of military drone would have to do. A number of sensors, and you're basically creating one mechanical platform that we're going to place different sensors, different software in. And again, that means that I've got to manage much more possibilities. I have to manage all this electronics and software. I want to be able to test this in a virtual environment. Especially if you talk about a drone, I don't want to have to fly a drone and have it do bad things in the air. I want to figure out all that and find that inside a digital twin. So we're allowing customers to manage that complexity on a scale like they've never managed it before, simulate that and use that inside a digital twin.
Yeah.
And really find and make those mistakes in the digital world before they're ever put out in the physical world.
Yeah, and another advantage of the digital twin scenario is we have our own conference called Predictive Aircraft Maintenance, which of course digital twinning in that is essential because you can run scenarios in a metaverse, get all the data back, and then make decisions based on that for the future. So you can be more efficient in terms of you operate your
and we didn't go there in immersive engineering, but imagine an AR-assisted headset that I can give a non-trained, a non-expert technician in Milwaukee talking back to the home base in New York, again for United Airlines, so they can help do that repair on that engine that they need. And it's just the possibilities of that collaboration and that assistive technology, it's just, the sky's the limit.
And that takes us on nicely to the final topic we're going to discuss, which is workforce, and how the industry copes with a lack of, especially we mentioned engineering, on the engineering side, a lack of experienced engineers. We lost a lot during COVID, and they're not coming back. You said before, this technology makes the industry a nicer place to work, which is an important thing. So we said before we started talking about this is probably going to be the biggest topic of this week. It was certainly in Paris last year. What's the industry doing? Is it doing enough to tackle the workforce issues? And if it's not, what should it be doing to try to do that?
So it's a multi-pronged approach, and as I like to say all the time, there's going to be far more money in aerospace in the next 5 years than there are people to spend it.
Right.
You look at sustainability, you look at advanced air mobility, you look at emissions on Mars, you look at all these countries that want to defend themselves and need products to be able to do that. There aren't enough engineers, there aren't going to be enough engineers, period, to do that, and all the executives at the air show know that. So certainly we're looking at education and bringing more students through our programs to do that, but that won't fill the gap either. It's digital transformation, led by a lot of these technologies we're talking about that's going to multiply the impact of my current workforce. And I think what we've got to do is we've got to say, you know, I may need 50 engineers to do this project, but the reality is I'm only ever going to have 30. And I may need, 25 technicians, and I may need 18 months to build this particular product, but the reality is I'm going to have 10, and I'm going to have to do it in 9 months. I'm going to have to compress those time frames. And digital transformation is a key fundamental way to help companies get there, because it automates and eliminates a lot of those mundane tasks that really human beings don't need to do anyway. It also helps us find problems so that again, because part of the problem in aerospace is I've got to go build something, fly it, find the mistakes, and then come back and fix them. Well, if I can get the initial product I built to be far more correct first, that compresses my timeline too. And it's a technology that builds on itself. Yeah. It helps me do the first iteration faster, and it makes that first release, that first iteration better, with fewer errors once I get there. And all that adds up to, as you said, also a better working environment, to a better environment to work in, and a much faster time to market. It's all those things.
And that better working environment, you know, I'll go back to the Formula One analogy. The Aston Martin HQ is it's not like an engineering workshop at all. It's more like a hospital. Absolutely pristine. It's not a dirty industry whatsoever. So it changes the way the industry is perceived as well, and that's probably important, isn't it?
Absolutely, because used to be that, you know, if I think about when I came out of college 30 years ago, the cool high-tech place to be was the aerospace industry. You know, that people aspired to be in this cool high-tech place. Well, there weren't all these other high-tech companies to compete with for engineers like myself when I came out of school in the late 80s. Well, now there are. And in the aerospace industry, we're competing. We've got to be on the cutting edge like all these other companies are for us to be attractive to these bright, new, great engineers, so that they want to come to the air shows like this and say, point up in the air and say, I built that. I helped design that, and I think there's nothing cooler than standing in a place like Farnborough, hearing a jet scream over my head and say, yeah, I helped create that.
Yeah. I get there's among some people, there's possibly again driven by Tesla or some of these, that they move from, we can create some software that does some stuff online, it helps people to purchase something or view something, but if I can use my time and ingenuity to create something physical, it's going to have a much bigger impact. Absolutely. Than a piece of software for social media or something like that, which might be cool, but really it doesn't make much of an impact. So that's probably the message the industry's got to get out.
Absolutely. That's a big part of it. Yeah. Absolutely.
And where are these people coming from, do you think? I mean, we're a global industry in aviation, so you know, potentially anywhere in the world. Is it shifting? Are we seeing the shift in where aviation is going to be more innovative going east, because you see the rise of the Middle Eastern carriers and into India and the Far East?
Certainly. I mean, ultimately aviation, like most industries, is financially driven. And as there's more finances and more financial ability in other parts of the world, you're going to see growth in those parts of the world. I think that's a good thing. It drives innovation, and we're certainly seeing that now, and we'll probably see more of that in the future. So no question that you're going to see growth in other parts of the world as demand drives it. No question.
Well, look, we have to wrap things up now, because our time is up, unfortunately. But it's been good to speak to you. Just a quick final word on the 5 days you're going to spend down here at Farnborough this week. What do you expect to get out of it as Siemens? What's the sense that you get from being here over 4 days?
I think the sense is we have a very, very healthy, vibrant aerospace industry. And again, more than 1,000 companies here trying to figure out how to do it better. You know, in more sustainable ways, in more effective ways, more time to market. And I think it's a fantastic time to be in aerospace. There are so many things we've accomplished, and with all the opportunities and technologies available to us, there's going to be so much more we accomplish in the future. As I said, you know, if there's young, innovative people listening, trying to figure out what career they want to be in, aerospace is it. Go to school, learn physics, learn math, become an engineer, learn to develop aircraft. aircraft. It is going to be a fantastic career for the next several decades.
Yeah, we could soon be seeing hydrogen or electric aircraft.
Absolutely, hydrogen, electric aircraft.
Is
absolutely, all kinds of things. Very exciting stuff on the horizon. All kinds of great stuff happening now. Much more happening in the future. That's what I'm seeing at the air show.
And a lot of effort goes into this. You look around. There's a lot of chalets to my right.
Yep.
Huge, big halls full of gear and kit and everything. So a lot of effort goes into this. That aircraft on the apron. Still important to get together like this and put this effort into being an industry that comes together.
Reminds us why we do what we do.
Yeah, good. As well as the noisy aircraft, although they've gone quiet now.
That's right.
That's right. But look, Todd, thanks for that.
Thank you.
Really appreciate you spending time with us today.
It's been an honor being on your podcast. Good to talk to you today.
It's been an honor having you. Thanks a lot.
Thank you.
Thanks, Todd. We are delighted that our friends at Amadeus have agreed to be the launch sponsor for ABNcast. And while they do not endorse the views and opinions expressed, they are keen to support a new forum for debate around the future of aviation. Today's traveller expects to be wowed way before they arrive at their destination, and passengers want a smooth, effortless journey, combined with exceptional personalised experiences. Embarking on such a major transformation to become traveller-centric retailer isn't an overnight journey though, so how are airlines adapting? Well, you can discover how they are seizing the opportunities afforded by new technology in Amadeus's Travel Technology Investment Trends 2024 Airlines Report. Key findings show 50% of full-service carriers are planning to spend more on technology this year than in the previous year, and 58% of low-cost carriers cite innovation as the top technology investment driver over the next 12 months. In the report, you'll also discover key objectives driving technology investment for both full-service and low-cost carriers, aspirations of airlines on the journey to modern retailing, and the technologies expected to make the greatest impact on the industry. You can download the full report now on www.amadeus.com. Just go to the Resource Centre and you'll find it in Research Reports. And don't forget to subscribe to ABNcast on our YouTube or Spotify channels to make sure you don't miss future episodes. Thank you very much.